Contamination analysis in sediments. Sediments are a sort of fingerprint for environmental pollution. The waste generated by human activities can wind up, on many occasions, at the bottom of the sea. The control and management of sediments is critical to the health of the planet. But traditionally, they have received little attention, probably because we can't see them. Until now, the analysis of these sorts of samples has been carried out through a complex process, especially when trying to find the presence of heavy metals. A research team within the Faculty of Marine and Environmental Sciences at the University of Cádiz, led by Dr. José Luis García and Dr. Rocío Rodríguez, studies superficial coastal sediments where the presence of pollutants can prove most dangerous. They are seeking to develop a rapid evaluation technique for pollutants in sediment, which is especially useful in areas with high population density or industrial activity. The group uses a technique to analyze samples called thermogravimetry, which consists of heating a small portion of sediments to see how its weight varies throughout the process. They are the first group to have applied this technique to the analysis of sediments, and the results have been quite interesting. Analysis is much faster than the habitual technique. It does not generate waste, allows for the measurement of organic matter, and indirectly checks for the probability of the existence of heavy metals in the sediment. Many of the indications in sediment related to environmental quality are basically used as an indicator of the presence of these metals, which are dangerous to the ecosystem and for our own health. A key concept for evaluating the level of danger of different pollutants is their bioavailability, which is the capacity of the metals to interact with living organisms and the ease of incorporation into the body. When heavy metals are found in marine sediment at a certain depth and without oxygen, they often tend to be in the form of insoluble sulfides, which are not harmful to the ecosystem. However, in intertidal areas, or when the sediments are disturbed, such as during dredging, oxygen can come into contact with the insoluble metal compounds, oxidizing them and making them water-soluble, and thus making them available to living things. When sediments are rich in organic matter, they are more susceptible to contamination because they associate with heavy metals to form organometallic compounds, which may also be dangerous to organisms. The mouths of waterways and places where sewage is dumped are high-risk areas, which is where researchers test most frequently. In Andalusia, most of the drainage networks are linked, so that rainwater is channeled along with sewage. With these analyses, researchers can demonstrate which areas are most susceptible to heavy metal contamination, helping to optimize possible environmental safety plans. Another technical application is the ability to track decontamination treatments in order to gauge their effectiveness. Controlling marine sediment contamination is crucial for the ability to preserve the rich and abused natural resources that are our seas.